Have you ever wondered how a company like Netflix can serve over 200 million users at the exact same time without ever going down? How do they do it? Well, it's not with one single giant application. It's with thousands of tiny interconnected services. And that right there is the power of microservices architecture. So let's break down how the world's most scalable systems are actually built.
So just look at the difference here. On the left, you've got the monolith. One single, massive block of code. It's simple to start, for sure, but it can get really rigid really fast. And on the right, that's microservices. It's this whole network of small, independent services all working together. Now, this is more than just a different diagram. It's a completely different philosophy for building software. Let's dig in.
So why do we even need to invent microservices in the first place? Well, it all starts with what we call the monolithic trap. See, a monolith is kind of the default way you'd build an app. It's all one big, self-contained unit. And that's fine at first, but as you add more features, more code, and more users, it just starts to creak under its own weight. The bigger it gets, the slower and more fragile it becomes.
And that leads to these three big headaches. First, deployments are a total nightmare. You change one tiny line of code somewhere, and you have to redeploy the entire massive application. Second, it just turns into what engineers call a big ball of mud. Just this tangled mess of code that nobody really understands anymore. And third, scaling is all or nothing. If one small part of your app gets a lot of traffic, you have to throw more servers at the entire thing. It's just incredibly wasteful.
So, out of all that frustration came a totally new way of thinking, the microservice approach. And this isn't just about taking a hammer to the monolith and smashing it into pieces. No, it's a really strategic decision to build systems that are flexible, scalable, and resilient right from the ground up. So what are we really talking about? Here's the classic definition, but let's look at the key words here. Small services. Each one is built to do just one thing and do it really well. Each running in its own process. This is crucial. It means they're completely independent of each other and communicating with lightweight mechanisms. They talk to each other over simple, standard APIs. It's all about breaking down a huge problem into small, totally manageable pieces.
And this right here, this gets to the very heart of the microservice philosophy. Organized around business capabilities. That means you structure your teams around what the business actually does, not around tech layers like database team or UI team. Decentralized governance means the payments team can use a totally different technology than the shipping team if it makes sense for them. And design for failure. This one is huge. You build your entire system with the assumption that things will break, and you design it to handle those failures gracefully.
Okay, so we've got this city of services all running. How does a single request from a user's phone find its way from the outside world to the right service, and then all the way back again? Let's trace the path of one of those requests as it travels through this distributed landscape.
A request doesn't just wander into the system, It has to go through a single, heavily fortified front door, the API gateway. Think of this thing as the bouncer, the air traffic controller, and the receptionist all rolled into one. It checks your credentials, it makes sure you're not trying to overload the system, and then it directs your request to exactly the right service inside. It's absolutely key to managing all the complexity. So, once a request is inside, the services need to talk to each other. And there are two main ways they do that. Synchronous communication is like a phone call. You call another service, and you wait for it to answer and give you the information you need. It's fast, but if the other service is busy or down, you're just stuck waiting. Asynchronous is more like sending a text message. You fire off your request into a message queue and you can get back to doing your own work. The other service will pick it up and respond when it's ready. It might be a tiny bit slower, but it's way, way more resilient. And now we get to what is honestly the biggest, most difficult challenge in the entire world of microservices: data. See, when you split your application up into all these little services, you also have to split up your database. And that creates a massive headache. How do you keep everything consistent across all of them?
Right. Here's the problem in a nutshell. Imagine you're buying something online. The system needs to do three things: charge your credit card, update the inventory, and create a shipping label. In a monolith, that's easy. It's one big database transaction. But in our new world, that's three separate services with three separate databases. So how do you make absolutely sure that either all three things happen or none of them do? Because if the payment goes through but the inventory doesn't get updated, you have a very, very unhappy customer.
The root of this whole problem is actually a core principle of microservices. Each service owns its own private database.
The user service has no idea what the order services database looks like, and it shouldn't. This is what gives us that independence and scalability that we want, but it's what makes consistency so hard. This is the fundamental trade-off you make when you choose microservices. So, the solution is a really clever pattern called a saga. Instead of one big all-or-nothing transaction, you have a sequence of small, local transactions that are all linked together by events. So the order service creates the order and then passes the baton to the payment service. The payment service does its thing and passes the baton to the inventory service. It's like a relay race for your data.
But what happens if somebody drops the baton? Let's say the inventory service fails for some reason. Well, the saga just goes into reverse. The inventory service basically sends out a distress signal. That signal tells the payment service, hey, you need to issue a refund. And that, in turn, tells the order service, you need to cancel this order. It's a self-correcting system. It might be a little messy for a second, but it always gets back to a consistent state. We call this eventual consistency.
Now, there are two main ways to manage these sagas. Orchestration is like having a movie director. There's a central controller that tells each service exactly what to do and when to do it. It's easier to follow, but if that director goes down, the whole production stops. Choreography is more like an improv team. Each service just listens for events from the other services and reacts accordingly. There's no single point of failure, but it can get pretty chaotic and hard to follow the plot.
All of this, the sagas, the asynchronous communication, it all points to a fundamental shift in mindset. In the world of microservices, failure isn't just an option, it's an absolute expectation. You don't try to prevent failure, you embrace it, and you design your entire system to be resilient in the face of it. This mantra from Amazon really gets to the heart of the DevOps culture that you absolutely have to have for microservices to work. You build it, you run it. What that means is the same team that writes the code is also the team that gets woken up at 3 in the morning when that code breaks in production. This creates an incredibly powerful feedback loop that forces developers to think about reliability from day one. One of the most important tools for building these resilient systems is the circuit breaker pattern. And it works just like the circuit breaker in your house. If a service starts to fail over and over, the circuit breaker trips and temporarily cuts it off from the rest of the system. This stops the problem from spreading and causing a domino effect, and it gives that failing service a chance to recover. It's a simple idea, but it is incredibly effective at preventing system-wide outages. Okay, in a microservice world with hundreds of services, you can't just log into one server and figure out what's going on. You need superpowers, and that's what observability gives you. You need 3 key things. Distributed tracing lets you follow a single request as it bounces between all the different services. It's like a GPS for your data. Metrics give you a real-time dashboard of your entire system's health. And centralized logging lets you search through all your logs from every service in one place. Without these 3 things, you're flying blind. So, after all that, you might be thinking, okay, microservices are the answer to everything. I should always start with them. But here's the surprising truth. You probably shouldn't. The complexity that comes with microservices is a really heavy price to pay, and you shouldn't pay it until you absolutely have to. The best advice is usually to start with a well-structured monolith. Then, only when it starts to buckle under its own weight, should you begin to carefully break it apart. Microservices are a destination, not a starting point.